Hello, hello. Good afternoon, one and all here. I request all the students to please put their mobile phones on silent mode. Students are requested to please put their mobiles on silent mode. Hello. Am I audible at last? Am I audible? Good afternoon, everyone. I request all the students to please be quiet. नहीं ठीक है. So with your permission, shall we start the event? Good afternoon, one and all. I, Dr. Anjali Jain, welcomes you all to the celebration of National Science Day Track 2. National Science Day is celebrated in India on 28 February each year to mark the discovery of Raman effect by an Indian physicist Sir C.V. Raman on 28 February 1928. For his discovery, Sir C.V. Raman was awarded the Nobel Prize in Physics in 1930. National Science Day is celebrated to spread a message about the importance of science used in daily life for the people, to display all the activities, efforts, and achievements in the field of science for human welfare. It is celebrated to discuss all the issues and implement new technologies for the development in the field of science, to give an opportunity to the scientific-minded citizens in India to encourage the people as well as popularize science and technology. And that is why we are here to celebrate this day. And with us, we are having Dr. Naki Anwar. A big round of applause for sir. And Dr. Arvind Kumar Singh, who have joined us online. Before we listen to the enlightened talk, I would like to request Professor Dr. M.K. Pandey, sir, Joint Head SA, to please deliver welcome address. Please, sir.
Good afternoon. Naqvi ji, Dr. Arvind ji, who has joined us online, my colleagues, Dr. Basant, Dr. Tomar, Dr. Thakur, and all the faculty member and their students. On behalf of our most respected presidency, on behalf of our Honorable Chancellor, Sir, Vice Chancellor, Madam, on behalf of the Amity family and my own behalf, I would like to welcome our guest for today, Dr. Naqvi and Dr. Arvind. And we are thankful to them, those who have spared his valuable time and decided to be among us this afternoon. Thank you very much for coming to our campus, sir. Students, you know that is the whole world and India especially is of most respected scientist of the country, Dr. C.V. Raman, who have founded the Raman effect. And you know that the Raman effect and the scientific discovery at that time was unique, was incredible. And since India is right now observing and is the host for G20 presidency, so the tagline, the motto for this year's National Science Day is the global science and global well-being. How we can convert the scientific things, how we can ask the scientific innovations for the global well-being is the now this year is the world is collaborating. And that everybody knows about what the Dr. Raman has been founded and this effect was founded. And when Dr. Raman was called to England for a lecture like this, and that time he was traveling through the ship, and during his return journey, just observe that when the sea and the sky is meeting, at the time, at that place, the color of the sea is changing to the dark blue. And this was wondering the scientist, because the scientific community, scientific minds start with thinking, observing, and the observation that has been taken by Dr. Raman was taken up back to his laboratory in Kolkata, and the effect was being founded. And in 1928, his effect was being given. And the whole world was at a storm because of this discovery. And which says that whenever the light beam come into any of the surface, liquid surface, then part of that light beam will get scattered. Now see the difference, see the science behind it. And this scattered light will have the information, the characteristics of the material from where it is getting scattered. Now that time they must have not thought about that much extent. However, now if you see the medical science, how it has been changed, how medical science has been affected due to this discovery. So now even today, when we are talking about the scientific innovations, how this science has been evolved over the period of time, and what is the relevance of the new scientific discovery as the contemporary times. You know that the world is facing and has faced a lot of unprecedented situation in the last 2-3 years. When we have seen the pandemic, and the pandemic has struck the whole human life, and the world is facing the situation like the war situations. So in that, this time, the motto has given as per the G20. India is having the G20 presidency. So India's motto is global science for the global well-being. Now let us take the science for the well-being. And science have all the capability, all the capacity, how it can convert the human being and make this world most livable. And science mixed with the technology can make a lot of significant changes in the world we look at, and that we have seen. And nowadays we are talking about various disruptive technologies like the artificial intelligence. We are talking about the blockchain technologies, and we are talking about the quantum computing. And the fundamental, the basis of the quantum stands from the scattering. The moment the light, the particle effect of the light will come, and that will be scattered, and then quantum effects will come. So if you go back 100 years back, then the quantum computing concepts has already been given by Dr. C.V. Raman, which right now we are making the application in various fields, including the computer science, including the calculating the deep data analysis and all. So, dear students, science have a lot of capability, lot of capacity, and let us make it better for making our life better. The world is better place to live. So with this, today we have Dr. Naqvi. We are here to listen to him today. So thank you very much, and once again welcome to Amity University.
Thank you, sir. Thank you, sir. It was indeed a great pleasure always to hear you. And you have already tell us many things about Science Day. And before moving further, I would like to request Professor Dr. Abhay Bansal, sir, Joint Head Asset, to please address the gathering. Over to you, sir.
Thank you, Dr. Anjali. On behalf of our most respected Honorable Founder President, Dr. Ashok K. Chauhan, Honorable Chancellor Dr. Atul Chauhan, I welcome Dr. Naqvi Anwar, who is Professor and Head with Department of Sustainable Engineering, TERI. Thank you, Professor Naqvi, for spending your valuable time to be with us. Our Civil Engineering Department is already working with TERI School for various collaboration and joint projects, and we look forward to have many more tie-ups. I also welcome Dr. Arvind, who is Scientist, Engineer SG with ISRO. Thank you, Arvindji, for spending your valuable time to be with us. Just for reference for all learned speakers, as you are already aware, we have 11 universities, 2 more coming up, one in Bangalore, another in Hyderabad, We have 17 global campuses having in US, London, Singapore, Dubai, Mauritius, China, Abu Dhabi, South Africa, Romania, Nairobi, Tashkent, Paris, Sydney, and coming up another 50 campus in next 10 years as per the vision of Honorable Founder President, Honorable Chancellor. And we look forward to see various collaboration, and we are here to celebrate Science Day. A lot of contribution we together have to make, and we all have to work together to make world as the best place to live. So we look forward to have delegation and deliberation, and looking for various collaboration. Thank you, Dr. Anjali. Wish you all the best.
Thank you, sir. Thank you for your address. Yes. Now we have with us Dr. Naqi Anwar. Dr. Anwar is professor and head of the Department of Sustainable Energy at TERI School of Advanced Studies, New Delhi, earlier known as TERI University. He also heads the Internal Quality Assurance Cell, IQAC. Dr. Anwar has an experience of more than 20 years of academics and research. He is an electrical engineer by training and doctorate in smart grid management. His academic and research activities include renewable energy and grid integration, microgrids, smart grids, grid level battery storage, and mobile substations. He has published 50 plus research papers in conferences and journals of international repute and authored 8 books. He is an invited member of IIT Bombay as a member of Committee for Research in Energy Education. He is a visiting faculty at Linnaeus University, Sweden, and having strong international research collaboration with Edwin University of Technology in Netherlands, University of Strathclyde in Scotland, KTH Royal University in Sweden. With this brief introduction, I request Dr. Anwar sir to please deliver his expert talk on sustainable growth of energy sector in India. Please, sir.
Formal good afternoon to all. So, first of all, I would like to thank Dr. Manoj Kumar Pandey for setting up the context very beautifully. So, without wasting much time, I'll just directly come to the topic sustainable growth of energy sector in India. First of all, what we need to understand that why the world is looking at us now for finding the solutions for those problems which has been created by the developing countries, for the developed countries. Like say, if we talk about the climate sustainability, G20 presidency which came to us, it is just because the world relies on us that ultimately we will find some solution for the legacy carbon which is already exist in the atmosphere. Every country is talking about their net zero targets. I think we must realize that becoming net zero will not suffice our requirements in the future, because if we talk about the sustainable growth, that should be futuristic. What about the legacy carbon? What about the carbon which has already been in the atmosphere that has been produced by the developed countries already? So first of all, we need to understand that India is great is a statement, or it is really our signature. So for that, whenever we say that India is great, we must also, from the quantitative verification, realize that the world relies us, because really India has the potential to not only be great, but also to provide an inclusive solution to all the problems the world is nowadays facing. So if I just start my presentation with a brief of growth of energy sector in India and its global context, I'll start with some of the key indicators based on which any country's development growth is being measured. So you can see that as we progress from 2000 to 2019, in all aspects of growth index India has progressed. Whether it is GDP, as percentage of global average, in 2000, it was just 23%. But now it is around 44%. Similarly, energy demand per capita, as a percentage of global average, in 2019, it was just 28. But now it has increased to around 33% and increasing further. Similarly, on every aspect of growth index, whether it is oil demand per capita, coal demand, residential energy use, steel and cement, car ownership, or CO2 emission, you will find in every aspect, India is progressing. And these data, which is from 2000 to 2019, if you extrapolate it, you will find what is the true rate at which we are growing. Now, if I just concentrate on three main indicators: population, GDP, and the energy demand. Here, I must clear that I'll slightly be non-technical in my presentation and avoid the technical part of it. And secondly, what we need to understand that energy is not only about electricity. Energy is beyond electricity. Coal, oil, used in transportation sector, used in our cooking, all these are part of the broader theme that is energy. But of course, electricity is an integral and the most important part of energy. And that is why we will focus on electricity as well. But as of now, if you look at this three main indicators of growth, you will find that our energy demand is continuously growing. In 2000, what demand we had is basically fulfilled by coal, oil, and traditional biomass only. But nowadays, our demand has increased manifold. But coal, oil is still dominating to fulfill our demand. But if you look, what is the new entrant is significant amount of renewables into the electricity sector and energy sector, which is fulfilling our demand. Now, if we look at the policy measures or the measures which by inherently India has adopted as policy and created a scenario, that scenario is called stated policy scenarios. So that scenario will let us know that we will continue to grow till 2040. This step scenario is being calculated by International Energy Agency, and all these presentations, whatever I am making, is basically the data taken from International Energy Agency. So if you look, you will find that India will not only capable of providing to the solution which is adopted by developed or developing countries, but also to those particular factors which is new entrant into our energy arena, like solar PV capacity, like battery capacities or grid level energy storage. So you can just witness that by the year 2040, even if the policy, whatever we have in existence as of now, we will continue to grow. And the total energy storage, battery level energy storage, will account for 30% of the total installed capacity as of now. So that increase is basically looking at three main factors. That is the drivers, the energy demand, and its impact. So if I look, you will find that if we make a comparison between what the values were in 2019 and what are the values in 2020, you will find that renewable energy and other technologies are the one where we have seen a positive growth. So for an annual average between 2015 and 19, the growth was 8% for renewable and others. But in 2020, the only thing which is positive where our demand grows is the renewable energy and others. Rest all, whether it is GDP, material demand, car sales, electricity requirement are all reduced. It means India is not only using electricity or energy, but they are now using it more efficiently with a touch of energy conservation in all their activities, which is again a positive sign, because one energy conserved is more than an energy generated, because obviously losses will not be there. Now, total primary energy demand, if you look and make a comparison between the scenario of 2000 and 2020, you will find that all the energy demand in 2000 were largely met by coal and oil. But as of now, our total energy demand is around 900 million ton of oil equivalent. And that is not only that coal and oil is contributing to that, but significant amount of modern renewable energy, which comprises of solar photovoltaic system, solar thermal system, wind technologies, and biomass related activities are also there. So it means we are not only depending upon what we have, but also exploring continuously to new technologies which can replace oil and gas and any fossil fuel based generation. Now, if I just let you go through the change in energy demand by fuel in selected and use sector, you will find that the total demand by the industry is almost 140 million ton of oil equivalent. Out of that, obviously coal and oil dominates, but electricity sector, which comprises a significant around 40% part of renewable energy, also is used by the industrial sector. Now, transport sector is largely dependent upon oil, which is imported oil as of now, but buildings and agriculture sector has continuously transforming themselves into the renewable energy electricity. Two important things: how many portion of population have access to clean cooking solutions, and how we are faring towards universal energy access in the form of electricity. So if you look at these figures, you will find from 2001 to 2019, our growth has significantly high. You can see that now around 700 million people has access to clean cooking solutions, whereas in the year 2001, it was less than 300. So it means our rise not only in electricity sector, but cooking fuel sector is also very, very important, because you must realize that large part of India is rural, and in rural areas also, if we are able to provide clean cooking solutions, it matters a lot. Maybe sitting in this room with so many fans around, we might not realize, but those who are into the rural sector or agriculture industry, clean cooking solution is a real problem for them. A large part of them is still using raw biomass and raw biomass based chulhas for their cooking solutions. So providing 800 million people that kind of solution is a big achievement. Similarly, access to electricity. In the year 2021, we have already declared that we are 100% electrified. All our villages are electrified. It is not only that we have said that. Yes, I agree that some of you may contest that it is not 100% electrification. there are still households where the electricity has not reached. I agree with that. But that is the problem with our definition. 100% electrification means that village is electrified. Now we are also targeting household level electrification. But irrespective of that, you can see from 2001 to 2019, it is around more than 1300 million people which has access to electricity. And that is the definition of universal energy access. If you find even in all the developing countries near around us, it is only India which can actually electrify 1.3 crore people in that short interval of time of 20 years. The growth tremendously increased from 2013. So India's sectorial share in employment, GDP, and energy consumption. Look at the figures. The sectorial composition of employment and GDP has shifted from agriculture over recent decade, but agriculture remains still a big source of employment in rural areas. You can see what is the change. We are not only dependent upon agriculture as employment, but the process industry and the services industry are also nowadays a big part of our employment sector. This is the annual power capacity addition each year. You can see that in the year 2019, we have added around 26 gigawatt of net addition, out of which wind and coal are below the wind. So solar PV and wind technologies are what we have started investing beyond 2014, much more. And that is our achievement in electricity sector. So this is the investment trend in energy and the 5-year annual average. So you can see that how many investments are going on in the energy sector. Oil and gas supply industry, around $10 billion had been invested in 2019. But a large part of it has been in the power industry as far as renewables, nuclear and fossil fuel based generation is concerned. Again, a growth index well taken by India. CO2 emissions from the Indian energy sector. Power industry is responsible for most of the CO2 emissions by India. But transport sector, industries are also equally responsible for that. And that is why we have a net zero target, that by the year 2070, whatever carbon we have produced, we will go for its sequestration. We will produce equal amount of oxygen into the atmosphere, and we will become carbon neutral by 2070. We have evidence-based fact for that. And at any forum, India can substantiate whatever they claim for. It is not like that we have just stated what we wanted to, but rather we have progressed, we have developed policies and started taking action towards our goals. So this is the electricity indicators in India. You can see our generation capacity and demand per capita. There is a gap. The violet line is our generation capacity and the demand capita is our green line. There is a gap. It means actually what we have as installed capacity is capable of providing or capable of catering all our energy demand. But the problem is mismatch, because the entire power system operation is all about mitigating the mismatch between available generation and the demand at a particular instant of time on real-time basis. And this real-time basis makes it more complex. So it is not like that our installed capacity, we cannot do it. Yes, we can do it. But there are operation complexities that needs to be addressed. Now the annual change between 2000 and 2015 to 2019, you can see This is the annual average. In 2020, what we are having is a less of generation because our demand has reduced. So if we go for steps, that is whatever policy we already have in existence, if we will try to achieve or our targets, you can see our energy demand will grow manifold. The total demand will go above 450 gigawatt. Now, are we capable of generating 450 gigawatt? Yes, we can, because our residential demand will go on increasing and increasing, mainly because of our HVAC loads, which is continuously growing, urban population, which is continuously growing. So what happens that if you look and compare this scenario, you will find that this is the change in installed capacity. And if we go for steps, that is our state policies, which has been adopted, you will find that the use of coal will continuously reduce. The use of solar photovoltaic technology will continuously grow, and other technologies being more or less remaining same. So by the year 2040, even if the policies right now in existence will achieve us for whatever target we had. This is two more scenarios which has been in place for the policymakers and those who are into the policy research, called sustainable development scenario. You might be knowing that COP21 or the Paris Agreement has given 17 cross-cutting goals, that is called sustainable development goal. And India has already ratified to achieve those sustainable development goals. So if we can achieve those sustainable development goal, that scenario is over and above our existing policy, and that is called sustainable development scenario. A more progressive scenario is given by our honorable our honorable Prime Minister, and that is called IVC, that is called India Vision Case, where we have shown that whatever we have achieved and whatever we can, we need to push slightly more, and we will achieve more. Going, I think. Okay, so if you look, you will find that solar photovoltaic capacity is growing fast. In SDS scenario, by the year 2040, whatever we have targeted for, like 437 gigawatt of renewable power generation, it is not far behind. If we just make efforts towards what we wanted to achieve, we will achieve that. Yes, we have missed our target of achieving 175 gigawatt of renewable energy generation by some figures this year, that is by 2022. But it is basically the solar rooftop sector due to which we could not achieve our target. But yes, if you look, whether it is wind, coal, battery storage, all is progressing like an exponential figure, that is manifold growth. It is not linear, it is non-linear. So this is CO2 emissions and GDP, that is gross domestic product per capita by region. You can see for India, if we will go for steps, it is difficult to achieve our target. The dotted lines actually indicates what we need to do to achieve. So you can see still we are growing our GDP, and right now our GDP is around 3 trillion. That is significantly good. India has already been identified as one of the fastest growing economy in the world. And currently it is 5th fastest growing economy in the world. And if we can achieve that SDS, that is Sustainable Development Goal scenario, then you can see that we will be able to address our GDP that will continue to grow. Still, we will reduce our CO2 emissions. So achieving the same GDP with around 1,000 kiloton of CO2 emission in the atmosphere, which is significantly low compared to any other country if you compare with Europe or United States. So this is why I said in my initial discussion that it is not like that India is great is just a statement, but it is basically our efforts which has been adopted and convinced the developing world that we can achieve that. Global RE scenario and India's legacy. 135 countries have renewable power targets. India is one of them. 150 countries have renewable power regulatory policies. India is one of them. 3,146 gigawatt of global installed capacity renewable power is still available. So more than 50% of climate mitigation finance allocated to hydropower, PV and wind. So the world is not investing in coal and oil, but yes, we must realize that in the next 50 years, our share may reduce, but coal and oil-based generation will be there. So this is the annual addition of renewable power capacity. You can gigawatts. This is how the top 10 countries and rest of the world contributing towards hydropower. Rest of the world accounts for 30%. India is basically 7th largest capacity added in the world last year. Global investment in renewable energy power and fuels. World is investing towards solar photovoltaic and wind power. And around 366 billion US dollar has been invested in 2021. Out of that, more than 90% investment has been made in solar and wind sector. Very promising because we have a market and we are creating the market. This is how the other comparing other countries, United States, Europe, America, Brazil, India. Yeah. Thank you. So India is predominantly present in all aspects of energy sector and progressing fast, and it is not only that developing countries, India, Pakistan, Nepal, Bangladesh, Bhutan. Now we are being compared with European Union, United States, China, Africa combined together, because the kind of contribution we have made in the last decade is not just by a country, but it is comparable to some of the continents even. Now it is the global electricity production in 2021. You can see that India has contributed around 1,670 billion units. This is the electricity we have produced last year, that is 2021. And this is the global electricity consumption. So we are not only producing, but also we are consuming. It means we are making use of our electricity in a right manner. And this is because of more urbanization, that is more population moving towards urbanization. This is the Indian electricity sector currently. You can see that still coal accounts for around 51.3% and renewables is 40.9%. That is significantly growing. And if you look at the number of units we have contributed in our power system, you will see that around 150 billion units have been contributed just last year. So this is again significantly high. And what is significantly good is our contribution towards the renewable energy. And in the renewable energy sector, you can see hydro, wind, and solar. The total installed capacity as of now for solar photovoltaic system is around 65 gigawatt, one of the largest in the world. Wind, it is around 42 gigawatt. You might not be knowing that it is our solar installed capacity is greater than Nepal, Bhutan, Bangladesh combined together, their entire power system installed capacity. So this is the kind of contribution we are making towards the world. There are Indian electricity legislations, that is by rule, by act, by bills we have passed. It is a long journey. Our journey of Indian electricity legislations started in 1910, that is pre-independence, when Indian Electricity Act has been passed. And for the first time, a rule has been framed that how electricity will be distributed, who will be the licensing authorities. Then in post-independence, this has been changed to the Electricity Supply Act, and all the powers have been given to state electricity boards, which has been amended several times before 1998, when Electricity Regulatory Commission Act has been formed. In 1975, for the first time, open access in generation has been created. That is, anyone can come and start generating. Similarly, state electricity boards have been given the authority to provide license to the generating authorities. But in 1998, there are 4 significant bodies came into existence. First is CEA, that is Central Electricity Authority, which is the main advisory to the Ministry of Power, which regulates all our technical and non-technical demands and its governance. Then CERC, that is called Central Electricity Regulatory Commission, SCRC, that is called State Electricity Regulatory Commission. These are the bodies which is responsible for tariff fixation. That is, at what rate you will be selling the electricity. India is a complex country because the same electricity which is being used by a residential sector, by an industries, and by agriculture are being sold at different tariffs. Agriculture is getting it for free. Industry is getting it at higher rate. Residential is getting it at subsidized rate. So complexities are more, but we have the policies intact. And then come in 2003, the Electricity Act. This is a game changer. For the first time, we have thought about laying down policy reforms and a solid framework for promotion of private participation in all the sectors. Not only generation. Generation we have already opened in 1975. But in 2003, basically, we have gone for private participation in generation, transmission, and distribution. The national tariff policy came into 2005 to determine at what tariff who will be using the electricity. In 2006, basically, national tariff policy under the head of National Electricity Policy came into existence and enacted. The National Electricity Plan has been proposed in 2012, and in which we have targeted that we will go for 80 gigawatt of renewable energy generation, out of which 20 gigawatt was the target from solar photovoltaic systems. But in 2015, we have revised our target, and we have revised it to, we have given 5-fold increase to our solar photovoltaic targets from 20 gigawatt to 100 gigawatt, 60 gigawatt from wind, and then 15 gigawatt from biomass and hydro. So 175 gigawatt was the target by the year 2022. Out of that, around 110 gigawatt we have already installed. Yes, we are short of our target, but it is basically the solar rooftop sector which is responsible for that. Anyway, then 2016 new tariff policy came, and debundling has been carried out, and DISCOMs have given the power in order to propose a new tariff based on their financial health. Then Electricity Amendment Act has been produced in 2021. I'll also come how this journey, what are the salient point of this Indian electricity legislation journey. And the Energy Conservation Amendment Bill, which is existence now in 2022, has been passed. So this is the evolution of our power sector reforms in India. As I have told you that we have started our journey in 1910 with distribution licensee to local government. Then in 1948, the creation of state electricity boards were there. And state electricity boards were empowered because at that time, formal states were not there, provinces were there. And that is why decentralized system of electricity distribution were thought to be more useful, which has been converted into a national grid later on. Then Regional Electricity Board came into existence in 1964. And this is the journey we have gone through. In 1991, one of the good thing happens that RBI, Reserve Bank of India, allowed 100% FDI in power sector. That is, any foreign company can start investing in any sector, whether it is generation, transmission, or distribution. And it is in order to promote the private participation. Electricity Act 1998 has given powers to SERC, CTU, Central Transmission Utility, and State Transmission Utility came into existence. Then the game changer Electricity Act 2003, which I have already told you that there were many things came into existence in that one. So these are some of the journey important points. And there is one important point is open access for a connected load of 1 kilowatt. Open access. That is, if there is a power plant, that power plant need not to find a local load themselves. Suppose Tata has a power plant in Gujarat and they want to bring the power generated at Jamshedpur in Bihar and use it in Gujarat. So they are allowed to do it through open access. They don't need to actually pay any wheeling and banking charges if their connected load is greater than 1 megawatt for all type of electricity, and it is greater than 1 kilowatt, 10 kilowatt if it is coming only from renewable energy source. So that open access also played a very, very important role, and those players which has business in multiple sector has increased their portfolios. Then 2017, 2016 and 2018 are golden years for Indian power sector, because in 2016 there was a scheme called Uday. It was with the sole purpose to improve the financial health of distribution sectors, because distribution sectors or the DISCOMs are always on a bad health, because they are the one which is responsible for providing the electricity to the end consumers. At the same time, they are the one which has the responsibility to collect the payment. So their financial health is always challenging. So I'll just because with the paucity of time, right now, the Indian electricity grid is divided into 5 regional grids, and these 5 regional grids are synchronized together. So right now, what we are having, irrespective of at what part of India you are, it is basically we are operating at 50 hertz. Now, this is the evolving power sector structure. That is right now, if you look, we are at that red arrow where the end consumer cannot choose their DISCOM. Like the mobile number portability we have, keeping the same number, we can change our service provider. But keeping the same connection, we cannot change our service provider if it is electricity is concerned. This is where we are looking for. And Electricity Amendment Act 2021 is actually specifically developed to facilitate that, which will take some time. This is some of the aspects of renewable energy, which is enacted in 2003, 2005, 2006, and then National Action Plan for Climate Change. So these are some of the factors which influences the positive growth of renewable energy sector in India. Income tax holiday, generation-based incentive, and accelerated depreciation are the 3 main factors. That is rebate in income tax, and generation-based incentive means if you are generating through renewable energy sources, then you will be incentivized. Similarly, accelerated depreciation are for the companies that they can bring the losses to their balance sheet in first 5 years of its operation if it is a renewable energy source. Others are renewable energy purchase obligation, renewable energy generation obligation, and renewable energy certificate. Also, there are low-cost funds available from IREDA, that is Indian Renewable Energy Development Agency, which is providing funds as a financial institution. Right now, it is 30-70 equity debt ratio, on the basis of which they provide the fund. So those who want to invest in renewable energy, they don't need to much problems. They don't need to face much problems as far as financing the project is concerned. IREDA is available for them. Renewable energy is future, because if you look at the investment, you will find that private sector is largely investing in renewable energy sector. Rest of all the organizations have started reducing their investment in other sectors, and this wagon wheel will give you an idea about grid and storage. Yes, government is investing a lot in grid and grid level energy storage, because obviously private sector is looking at profitability, and where uncertainty is there, private sector usually do not come into that one. Global renewable energy growing largely in solar photovoltaic, biomass, and hydro sector. Similarly, there are full-time jobs, especially predicted for India by IEA, that is International Energy Agency. And you can see that this is how the job market will. Electric and hybrid vehicles are the 3 main areas which will govern the market, the job market in near future. So conclusion, yes, we must say that our growth path is tremendously great. And it is evidence-based. I have already shown you, I have substantiated whatever claim we have made initially. The India's energy sector reforms are timely and need-based, and that is why the world relies on us. We analyze and we understand our own plan, and then we deploy it. Then India would be the global leader in Indian energy sector reforms and climate sustainability. Investment and employment market scenario will improve. Renewable energy, electric vehicle, green hydrogen, carbon credit, ESG, that is environmental sustainability and governance, are the future. So irrespective of which study you are doing as a student, whether you are from computer science background, whether you are from electrical engineering background, whether you are from civil engineering background, whether you are from management, whether you are from medicine sector, whether you are from pharmacy sector, always remember that if you do not have an idea about carbon credit, ESG, you will become obsolete in the near future. So irrespective of what is your background, you have to have an idea about renewable energy. You have to have an idea about electric vehicle. You have to have an idea about sustainable development goal. You have to have an idea about sustainability. So with this, I come to the end of my presentation. Thank you. As you know that I am from Terry School of Advanced Studies. I am professor and head in the Department of Sustainable Engineering. It is a deemed to be university in Vasant Kunj, New Delhi area. And we have only masters and PhD programs on different thematic areas of sustainable development goals. Thank you very much. Thank you for your patient hearing.
Sir, it was really a wonderful presentation. Thank you, sir, for enlightening us about your knowledgeable talk. I'm very sure that our budding engineers have been benefited by the things which sir has discussed right now. Most of you are from electrical engineering, so I think this is a very important talk which you must understand, which you must learn also. So thank you. So next we have with us Dr. Arvind Kumar Singh. Dr. Singh has completed his graduation from KLDAV College, Roorkee in 1992 and postgrad in physics in 1994 from IIT Roorkee. He has been awarded with PhD in 2000 in atmospheric science by IIT Roorkee. He joined Space Application Center, ISRO, Ahmedabad in January 2001 as scientist SG and currently working as scientist SG. He is currently working in the field of signal and image processing used for satellite data processing, including various categories of satellites like cartography, planetary, and astronomical. His research interest includes data and image processing, astronomy and astrophysics, leading-edge technologies like artificial intelligence and machine learning. His key roles for ISRO projects are Deputy Project Director, India's first astronomical satellite, AstroSat, Project Manager, Methane Sensor for Mars, Mars Orbiter Mission, Project Manager, Moon Impact Probe, Chandrayaan-1. He has been awarded with ISRO Team Excellence Awards, Chandrayaan-1, Mars Orbiter Mission, and AstroSat. With this brief introduction, I request Dr. Arvind Kumar Singh to please deliver his talk on space sciences, Quest of an Indian Mind. Over to you, sir.
Good afternoon. Are you able to hear me?
Yes, sir, you are audible to all of us.
Okay. Thank you for nice introduction. My name is Arvind Singh, as madam told. I'm working in a Space Application Center related to cartography, astronomical, and then planetary satellites. Basically, we are working in image processing, signal and image processing, and doing the data processing part. Here, I have given this topic, space sciences, Quest of an Indian Mind. Basically, there are lots of misinformation or more information or less information in the society regarding the space sciences, what actually it includes. And as ISRO, Indian Space Research Organization, So everybody is hearing the name of NASA, ISRO, ESA, JAXA. So what actually we are doing? So this is a glimpse of, I'm not going in details of each and every aspect. I'm just giving a glimpse of the space sciences activities, what we are doing in ISRO right now. Shall I start my presentation?
Hello. Yes, sir. Yes, sir, you are audible to us. You may start the presentation,
Okay,
please.
fine. Are you able to see first slide? So normally we start
Yes,
from,
sir. Visible to us.
normally we start from the Vikram Sarabhai. Actually, if you remember, he was the visionary and he was the first person to enable to make India enable for doing research in space sciences. And if I tell that some of his land, ancestors' land in Ahmedabad, he has given to the Department of Space by then Prime Minister Jawaharlal Nehru ji. So he has donated his land almost 200 to 300 acres to Department of Space. And you may be eating the ice cream Vadilal, if you remember. So Vadilal ice cream is basically the name of his father's, basically Vadilal Sarabhai. And he was a landlord. He was visionary. So he started space sciences in India with basically his vision was, we don't want to compete with the nations, those who are already doing the research in this field. So he wanted that this science and technology related to space should be used for the benefit of the common man. So his idea was very clear. And now with that objective, we started our journey in 1969. And recently we completed 50 years also. So let me start with this picture. So this is very easily available on the Google. This is a picture of Big Bang expansion. If you see this, this is highly acceptable, basically model of a Big Bang. You know that we started from an infinite small thing and then we grown bigger and bigger. Now this universe comprising billions of galaxies, billions of star systems, billions of other dying stars, regeneration, other things. So we came to existence and we have traveled almost 13.7 billion years from the 0 point. Now, the right side, if you see, this is the picture of our sun seen in UV ray. And then this is the earth, right side down. This is earth right now we are having. So what is the idea of this basically is that we have gone a very long journey to reach in this, basically in this, to reach at this point, what we are having, what we have right now. Now, perspective. So actually, let's start with the science and technology and human. What is their basically interaction? So why science and technology we do? Normally, there are two things. There are, we have one human need and other is the curiosity. Need is, you can classify basically food, clothes and shelter, roti, kapda or makan, and then finding resources, managing them better, having a good life. So that is called the human need. Then is a curiosity. Curiosity, I just showed the picture, earlier one. So it started with the Big Bang. Now, how we came to at this point? What is our existence? What will be our future? So around us, if you see around us, means if you see upward, if you see your beyond the earth system, your solar system, then you will be trying to find out the basically all your answers about your status and then your future. So science, technology, and new curiosity, basically they are in a loop system. If you increase your need, you have to go more for the more development. You have to do more research, and you have to develop more technologies. Then your curiosity again will arise. Your need will increase. So science and technology, need and curiosity. Basically, you will be in that loop ever after. As per say ISRO, what is our basically space science and technology? Normally, we are doing three things.
Sir, am I audible to you?
Yes.
Sir, I request you to please switch off your camera because your net is slow. So there is some delay from your end to us.
Okay.
So if you can switch off your camera, then I think it will be better.
Right.
Yeah, sir, it is perfect.
Okay.
Thank you.
There are three things we are doing in ISRO. We are doing Earth studies, planetary studies, and astronomical objects. So planetary Earth studies, basically, Earth is also a planet. So when we talk about the planetary system, we normally talk about beyond the Earth. So Earth studies, basically, we are doing for three things: life, quality, and sustainability. So how our life will work, and what will be the quality of our life, and how things are sustainable in this modern era. Like earlier talk, he was talking about the sustainable development for the energy sector. Then the planetary system. Planetary system, why we are studying is basically scope for expansion of life. If at all we have to leave this earth someday, then where we will go? Then our future resources. So future resources means like our energy. We drive by energy only. So energy is the main constituent of our planet. So if our all energy resources are done, then what we will do? Where we will get our future resources? Then astronomical object. Astronomical objects is done for the curiosity part. Is basically what is our origin, what was our past, and what will be our future. So better understanding of ourselves and our existence, scientific temperament, and technological development is the basic key of the space sciences as per ISRO's policy. I'm not saying about around the globe. Around the globe, people are doing different things, but ISRO is basically dedicated to these three things right now. India's participation, you can see these are the basically some snippets of Earth imaging. We are doing regional remote regional navigation. Then we are doing Chandrayaan 1, 2, 3 for moon mapping and moon meteorology. We have done Mars Orbiter Mission 1, and now we are going for Mars Orbiter Mission 2. We have done recently in 2015, we have launched AstroSat, and Aditya we are going to launch in 2023 last or 2024. So I'll go a little bit of all these things in the future slides. So let us talk about some basics. What are the satellites? What are the launch systems? And what are the orbits actually we are working on? So you know that there are three orbits. One is sun synchronous. Sun synchronous means whenever your basically illumination condition on the Earth surface is matching with the inclination of your sun. So every time whenever you come to a place at a particular lat long, so that will same illumination you will find, except for the cloud and other conditions. So that is called the sun synchronous. there is a geostationary and geosynchronous. Geostationary, so all our basically communication satellites stays at 36,000 kilometer. So this 36,000 kilometer, there is a orbit just above to the equator. So that is called the geostationary, because it seems stationary with respect to the Earth. And other is the geosynchronous, that is a highly elliptical orbit. And highly elliptical orbit is basically quite long, and that can be a 36,000 kilometer or 800 kilometer itself. So that we are using for our navigation and then our communication satellites. Sun synchronous satellites, basically we are using for the cartography purpose, our resource management. I'll come to that. Then there are circular satellites. Circular satellites, basically we are using for the purpose of astronomy and astrophysics. And we look upward, we don't look downwards on these orbits. Here is a small, basically when in 2017, we have launched 104 satellites.
Spacecraft and 103 co-passenger nanosatellites lifted off majestically on 15th February 2017 at 9:28 hours IST from SDC Sriharikota, the spaceport.
There is a camera on board we have kept, and we recorded each and every event of 104 satellites, basically separation. So you can see that it's a 1 minute
India.
movie.
Ground lift strap-on separated. Air lift strap-on separated. Heat shield separated. Second stage separated. The nanosatellites can be viewed from both sides, one after another.
You can see small satellites being thrown by the PSLV C-37 into the orbits. I'll skip little. You can see the series of satellites. Okay, now we have to launch when we are studying Earth, planetary and astronomy. So we have to launch in different orbits. So we have basically specified spacecrafts for this. So India's launch capability, we have added up to GSLV Mark III, that is a 630 ton itself and 42 meter height. So it can go up to the GEO basically platforms. GEO is geostationary platform. And obviously it can launch into GTO, LEO, Polar. GTO is basically geostationary transfer orbit. LEO is the low Earth orbit. Polar is the polar sun synchronous basically, and intermediate circular orbits. So these are the basically launch capabilities, and normally we are using PSLV for the for our Earth observation missions and astronomical missions, and then GSLV we are using for the planetary missions. Whenever the higher weight, high class weight satellites are there, then we are using the GSLV Mark III. So these are the type of observations. These are the examples, basically, what I have covered here. Earth observation, there is a Cartosat and ResourceSat. Cartosat is basically a mapping satellite. ResourceSat is for the resource management, knowing all the resources on the Earth or in India. Then planetary, Mars Orbital Mission and Chandrayaan 1, 2, 3. Astronomical, AstroSat we have launched, and now we are going for Aditya. Navigation satellites, there are almost 9 satellites we have launched in IRNS category. Now we are you also are going to have this navigation thing in your mobile next year onwards, based on the IRNSS. So Earth observations, what we actually do in Earth observation. So there are, I'm just telling that resource and management. Beyond that, there is resource management. So normally we cover agriculture, forestry, ocean, water, ice. Then meteorology, we cover weather, climate, renewable energy, precipitation. Then cartography and planning. We supply the data to the urban and rural ministries, Department of all the health, education, all the ministries we are giving, we are supporting in back end. Then we are doing urban mapping, rural mapping. Then we are also participate in the Digital India. Now, this right side, if you can see, so this is a Mithapur, Gujarat solar power plant. This is a very big plant near Mehsana. You can see that these pictures are taken from the ResourceSat, and you can see airport, Kuwait airport. This picture is roughly 1 meter resolution. You can see the Mumbai in natural color. Natural color means RGB, all 3 colors basically placed in the right perspective. Then digital elevation model. Digital elevation model is nothing but that finding the height of each and every point on the Earth's surface. Then glaciers, we are studying glaciers. We are doing the meteorology. Top right corner, you can see this is basically vegetation index. So vegetation index, what it tells about the what kind of your crop are growing, and then what will be the yield. This is the imaging capability. We have started from 1 kilometer. Then we went to 360 meter, 188 meter, 72, 55, 36. We zoomed in, and then now we are at 30 centimeter, that 0.3 meter. This is the latest. So you can say that a 30 centimeter object can be identified from the 500 or 600 kilometer from the top. So our capabilities have reached from kilometer to sub-meter. I'll show some pictures, basically interesting pictures beyond 4 or 5 slides. So you can look at the capabilities, what we have achieved in last 50 years or 40 years. So this is the pictures of Cartosat, portion of a port of Kuwait. I just showed the snippet earlier. You can see the lineup of the aircrafts. This is the Spain, Barcelona. You can see this is some oil refinery. You can count each barrels basically, and by seeing this picture, you can find out how much oil is being produced there. This is a high resolution natural color image, and this is the Qatar. This is one of the race course. The kind of clarity from 500, 600 kilometers. This is one of the product for Rome, Vatican City. Vatican City, you know that Vatican is the city and as well as the country. So this is the country actually. Right now you are seeing this is the Vatican and this is the true color and it is a 60 centimeter data. This is at Flight Center of USA, North Atlantic. So not only USA, we also do some spying. Shipping yard, this is a Dubai. Now you can basically just by seeing this picture, you can basically estimate what kind of transportation is happening there. This is Osama bin Laden hideout in Pakistan. And this is Corona 4 Soviet Union airfield. This is called target identification. Normally, we find a target in the image, we track it. It is just an example. It is not actually being done here. So, but if you see, this is a Sebarok Island in Singapore. You can see the ship, the sizes you can find out, what kind of material it can carry, you can find out. Then this is North Korea. North Korea is in very, you know, is very popular these days. Is in the news. So this is the launch pad. Basically, you can see right side here. And this is one of the worst disasters happened in Indian coast. This is Andaman Sea, and you can. This is basically before and after tsunami. This is Indonesia. You know the Indonesia. This is before tsunami, and this is after tsunami. So you can directly estimate what kind of loss you have got after the disaster. Now let us come to the planetary part. This is a picture actually. This is a movie created by me in 2008. This is a moon impact probe, and when in Chandrayaan 1, what we did basically we throw the moon impact probe on the lunar surface, and there was a camera moon imaging system. So continuously it was recording the images. So these are the images. I will skip. I will run in fast forward. So you will start seeing this is the disk. So it is like it is hanging in on the moon impact probe, and it is the disk. Right now it is very bright. After some time you will see the actual features on the moon. These are the basically you see the jumps now. They are basically frames put into the image, put into the video. So you know that normally whenever you throw a thing, basically is rotationally stabilized. So whenever because moon impact probe was thrown from the satellite on the surface, it was a basically hard landing. So it was rotating to basically maintain its velocity and direction. So kind of resolution when he was reaching to the just to the moon, and then it landed. So this is the Shackleton crater. It landed in the Shackleton crater, and that place normally we named as the Jawahar Sthal. This is the topography of in Chandrayaan 1, we were having a terrain mapping camera. There were 3 cameras in a single system. That is, one is nadir looking, means just directly downwards. 4 is for 25 degree ahead, and then 1 is 25 degree down backward. So if you combine these 3, you can create a topography, or you can create a DEM, digital elevation model. And when that digital elevation model you put into the moon surface, then this kind of movie you can create. So it's like a drone traveling on the moon surface. And these heights, if you see, they are 7 to 8 kilometers. Now let us few slides for Chandrayaan-2. You know that after Chandrayaan-1, we were very enthusiastic, and then we started with Chandrayaan-2. There were three components. One is the rover, one was the lander, and one was the orbiter. Lander and rover were in a single unit. Then orbiter, Chandrayaan-2 orbiter was there. So, and we basically we reached to the moon. Let me tell you, this is the information. Left side, top left side, if you see that this is a viewing gallery. This gallery is created at the SHAR, and anyone can go there and then see the live launches. So you have to book, I think, beforehand, and then go and then sit there. It is roughly 1.5 or 2 kilometers from the launch site. So you are not basically very, very high sound you will be able to see, and then light you will be able to see. So this mission Moon 2 was launched using GSLV Mark III. So we were having orbiter. Orbiter is still running, and then it is giving very good pictures. Then Vikram lander and rover. You know that Prime Minister itself was there and wanted to see how the lander Vikram landed on the moon, but we could not land. There was some issue, minor issues were there, and it crash landed. So we could not get the last few minutes basically data. And then rover also it destroyed along with the lander. But the reaching to the moon is a very interesting thing. Normally, we launched in the 22nd July in 2019. That was the liftoff. And then day 24, basically, we have injected the lunar probe into the translunar injection orbit. Then lunar orbit insertion we have done in day 30th day. Normally, you can reach to the moon by in just 5 days, but we took almost 48 days and just to reach the moon, just because that we wanted a favorable conditions to land on the moon. While before landing, you need to know where you are going to land. So this is basically like before doing anything, you know your data and you know your place. So this is called hazard map. So if right side below, you can see this is the hazard map. All the red part you cannot land. All the green part you can land. And this is the scale right now. Whatever you are seeing is roughly a 10-kilometer scale. So you can see actually a very less space is left to land on the moon surface. So this is called the hazard map, and normally we create it beforehand and then put into the system of the lander, and lander itself take decisions while landing on the surface. For planetary studies, normally do 4 things. One is topography, second is composition, in situ studies, and then search for water. You know that water is the most crucial part on the earth. Right now, next world war hopefully will be done for water. So in topography, we do basically what are the land undulations, how is land is there, what are the ups and downs. If ups and downs, normally up and downs tells about the mineralogy. You know that if you know the topography, so somewhere sun will be directly scorching on the land, and somewhere sun will not be very high. So that gives you the basically composition change in the land surface. So you know the composition. Then you do some in situ studies. You find the mineralogy, you find the water, you find the gases, you find the what kind of bacteria are there, what kind of viruses may be available, may or may not be. So these kind of studies normally we do. And I just want to inform everyone that ISRO Science Data Archive is there, ISDA. It is available at ISSDC, Indian Space Science Data Center. That is Bangalore, and normally we are hosting all the science data in ISSDC. So just type ISSDC, will take you to the ISSDC website. You can get all the data sets from here. Then Mars Orbiter mission, we launched on the 5th November 2013 and reached to Mars 24 September 2014, almost 10 months. And this is the one of the picture from the Mars. You can see this picture was taken by the Mars color camera, and you can see the right side there are two layers. This is the layer, actually this is atmospheric layer. The same time, contemporary MAVEN by NASA was launched, and we launched the Mars Orbiter mission. We took 10 months and we used the gravity of the Earth, took 7 rounds around the Earth, and then went to the Mars. But MAVEN it used a heavy rocket and then lift off and directly went to the Mars. So obviously they have done different experiments. We have done different experiments, but from the Mars Orbiter mission, one very valuable thing we came to know that there was a life on the Mars. And I was one of the instrument was there, Mars methane sensor for Mars. Basically, you know that if you study the methane of any surface, so you can know the biological component of that surface. So it is found that there is an abundance of methane is available in the surface, means there was some biological activity or some cultivation sort of things were happening in the past, in basically millions of years ago. These are the 5 instruments for the Mars. Lyman alpha photometer, methane sensor, then Mars exospheric neutral composite analyzer, Mars color camera, thermal infrared. So Lyman alpha photometer is basically D by H values, how basically water escaped from the Mars. Thermal basically is used for the mineralogy. Methane sensor basically used for the biological activities. MENCA is used for the what kind of interaction of the Mars atmosphere with the sun. So if you know the interaction of Mars atmosphere with the sun, then you can know the composition and you can so there if there is a possibility of life or not. These are the first pictures. Basically, while going to the Mars, we looked back and then took the picture of Earth. So fortunately, we pictured our India. And then while going to reaching to the Mars, we took the full Mars globe. Now we'll come to the AstroSat. Just 10-15 minutes more. I hope I'm okay with that.
Yes, sir. So, okay,
yeah.
sir, but I request you to please complete it in 5 to 7 minutes only. Otherwise, okay with the time also.
Okay, fine.
you.
Just going to complete. Now this is a WLM. This is a Milky Way. This is a 3 million light year faint dwarf galaxy. Basically, is found from in constellation Cetus by our AstroSat. This AstroSat, you know, this is a basically collaboration of Indian Institute of Astrophysics, TIFR, IUCAT, then RRI, Raman Research Institute, University of Leicester, CSA, Canadian Space Agency, and then Space Application Center. This AstroSat was having 5 instruments, and we developed all the data processing, then science payload data processing software. This is right side, if you can see, this is the first light from the AstroSat. It has seen the Crab Nebula. This is a Crab Nebula in the sky. A little bit more about AstroSat. What is the advantage of AstroSat? You know that AstroSat basically covers from ultraviolet to gamma. None of the experiments in around the globe, people are using this kind of wavelength to study the universe. So what you have to do, if you want to study a particular thing, you have to observe in each and every light. So if you want to know every chemical and every physical property of a particular thing, then you have to observe in the all different lights. So normally we are this astronomical experiments are done in infrared, ultraviolet, X-ray and gamma. So we have taken the ultraviolet, X-ray and gamma. These are the some interesting. This is the left side. If you can see, this is odd FS01. This is 9.3 billion light years from Earth. This is discovered by Astrosat, and it is one of the basically you can say a star system is found by the Astrosat. And then this is a right below. If you see, there is a detection of GRB, gamma ray burst. You know, the gamma ray burst is the wildest phenomena can happen in the universe. So what happens, basically a star burst itself and then release all energy at once. So you can see this is the GRB detected by the Astrosat. This is the Astrosat observation scheme. It was in circular orbit, and it has this is a gray part. You can see this is the sky scanning monitor, and all 4 other instruments were seeing one on its one side. You can see these are 4 instruments co-aligned. Then we are having INSS Gagan Navik program, navigation with Indian constellation. We have placed almost, there are 7 satellites written. Basically, 7 satellites will be working all together, and we have launched almost 9 satellites. And they are, we are in talk with all the mobile companies. Now we'll have a INSS based like a GPS thing you are having in your mobile. So we'll have a INSS also. Aditya L1 is basically to study the sun, and or basically, if you can say, the sun corona. These are the 6-7 instruments will be flying on the Aditya, and normally they will cover the corona part. What is happening inside the sun? Basically, we know that there is a fusion and fission process is happening. So what it actually, how it is happening, what is the source of light in the sun, and how we are getting the light. So all these things will be studied by the Aditya, and Aditya will be parked in the Lagrange point. So you know that Lagrange point is nothing but that the stable system between the sun and Earth. So when sun and Earth are taken together, so L1 will be the highly stable point, and L2, then L3, L4, L5. These are the stable points whenever you consider a 2-body system. So benefits of space sciences. Normally, whenever you do a space science, you get all physical health, wellness, psychological, cultural enrichment, management, organize and administration, political, financial and legal, educational. So all these benefits basically inspire to do more space sciences. I'll not go into detail. Basically, these are the spin-off of the space sciences, and it is more than 1,000. So, basically your quartz clock, pacemaker, mosquito killing systems coming from the space systems. This is my last slide. You can see a GCLV Mark III launch from 36,000 kilometers. So there is a camera, one of our satellite. It is just seeing the launch of Mark III, and it is being viewed from the 36,000 kilometers. And this is SHAR. Some just information, if you want to be basically space scientist or wants to join ISRO. Basically, sciences you can do BSc, MSc, PhD, physics, chemistry, maths, biology, agriculture, geography, geology, anything. Engineering, BE, MTech, MS, PhD, mechanical, computer, electrical, electronics, communication, from any good institutes. And we have one Indian Institute of Science and Technology at Trivandrum. Normally we train admission is through JEE only. And after that, you will be commissioned into the ISRO directly. Thank you. So if anybody wants to ask anything, can go ahead, or this is my email ID. You can note down, write me later also.
Thank you, sir. Thank you, sir. It was indeed a very good presentation wherein you told us about many things about the space sciences and how to join ISRO. I think that is of interest to all our students, and maybe some of them will be really interested in joining ISRO. So thank you once again, sir. Now I request Professor Dr. PM Tiwari, sir, to please deliver vote of thanks. There is an announcement for some of the students. They need to stay back. The names are Sahil, Araf, Rajul, Tanishk, Surya Pratap, Anush, Subhajit, Aditya, Kavya, Dhruv, and Dhruv. Okay, you need to stay back after this vote of thanks. Thank you, everyone.
So thank you, Dr. Anjali, for inviting me to propose the vote of thanks. At the outset, I would like to express our profound gratitude to our founder president, Dr. Ashok K. Chauhan, sir, who always motivates us to think beyond ordinary. He is the real source of inspiration for us to organize such kind of events. We most humbly thank to our Chancellor, Dr. Atul Chauhan, sir, for his constant guidance and motivation for aspiring excellency. I would like to record our deep sense of gratitude to our Honorable Vice Chancellor, Dr. Balvinder Shukla ma'am, for her dynamic leadership. My sincere thanks also goes to our joint heads, Professor Dr. M.K. Pandey and Dr. Abhay Bansal, for their active support and guidance for organizing this event. I express our profound, sincere gratitude to our speaker, Dr. Naki Anwar, Professor and Head, Department of Sustainable Engineering, School of Advanced Studies, TERI, for speaking sustainable on the topic sustainable growth of energy sector in India. Sir, you have presented a very useful fact to the audience about the current scenario of energy and its future prospects. Thank you, sir, for sparing time for delivering your talk. Equally, our sincere thanks goes to our second speaker, Dr. Arvind K. Singh, Scientist, Engineer, Space Application Center, ISRO. Sir, your talk on space sciences, quest of an Indian mind, is very contemporary and useful for our students. When India is has taken the target to make our country self-reliant in the space sciences and space sector, I hope the students have taken your talk very intelligently and they will be thinking to make their career in the space sciences. My thanks goes to Head of Department Electrical Engineering, Dr. H.P. Singh, sir, for his leadership in making this event very successful. We are thankful to all the Head of Department, faculty members, and my department colleagues, coordinators for organizing this event. And in last, my sincere thanks to all the students who have patiently was attending this event from last 2 hours. So thanks to all. Happy evening. Thank you.
Thank you so much, sir. With this, we come to an end of this session, and I hope you all have enjoyed the event and the talks by the different speakers. So thank you everyone. Now I request IT department to please close the session.
Thank you, Dr. Arvind. Am I audible?
Yes. Thank you very much. Thank you.
So sometime I would like to invite you personally in the campus.
Yeah, sure. I would like to.
Okay, thank you.